The nature of hypothesis testing. Null and alternative hypotheses, hypothesis test. Null hypothesis, a hypothesis to be tested. We use the symbol H0 to represent the null hypothesis. Alternative hypothesis, a hypothesis to be considered as an alternative to the null hypothesis. We use the symbol H to represent the alternative hypothesis. Hypothesis test. The problem in a hypothesis test is to decide whether the null hypothesis should be rejected in favor of the alternative hypothesis. Choosing the hypotheses. The null hypothesis for a hypothesis test concerning a population mean mu always specifies a single value for that parameter. The null hypothesis is expressed as H0 colon mu equals mu sub 0, where mu sub 0 is some number. Alternative hypothesis. The choice of the alternative hypothesis depends on and should reflect the purpose of the hypothesis test. 3 choices are possible for the alternative hypothesis: two-tailed test, left-tailed test, right-tailed test. A hypothesis test is called a one-tailed test if it is either left-tailed or right-tailed. If the primary concern is deciding whether a population mean mu is different from a specified value mu sub 0, we express the alternative hypothesis as H sub A colon mu does not equal mu sub 0. A hypothesis test whose alternative hypothesis has this form is called a two-tailed test. Example: the mean length of imprisonment for motor vehicle theft offenders in this country is 19 months. A hypothesis test is to be performed to determine whether the mean length of imprisonment for motor vehicle theft offenders in this city differs from the national mean of 19 months. Determine the null hypothesis. The notation for null hypothesis is H sub 0. Since we are given the mean length of imprisonment, we want mu. H sub 0 is always equal to, and the mean length is 19 months. The null hypothesis is H sub 0 colon mu equals 19 months. Determine the alternative hypothesis. The notation for alternative hypothesis is H sub A. We use mu since we used it for the null hypothesis. We need to decide if we're going to have less than, greater than, or equal to. We want to show that the mean length of imprisonment for motor vehicle theft offenders in this city differs from the national mean of 19 months. Differs means not equal to 19 months. The alternative hypothesis is H sub A colon mu does not equal 19 months. Classify the hypothesis test as two-tailed, left-tailed, or right-tailed. Since it is not equal to, we're looking at a two-tailed test. Alternate hypothesis. If the primary concern is deciding whether a population mean mu is less than a specified value mu sub 0, we express the alternative hypothesis as H sub A colon mu less than mu sub 0. A hypothesis test whose alternative hypothesis has this form is called a left-tailed test. Example: the mean local monthly bill for cell phone users in this country was $41.41 in 2001. A hypothesis test is to be performed to determine whether last year's mean local monthly bill for cell phone users has decreased from the 2001 mean of $41.41. Determine the null hypothesis. We begin with the notation H0. We are looking at the mean local monthly bill, so we want to use mu. H0 is always equal to, and the mean local monthly bill was $41.41. H0 colon mu equals $41.41. Determine the alternative hypothesis. We start with the notation H(a). We are using the mean mu. We need to decide if we're going to have less than, greater than, or equal to. We want to determine whether last year's mean local monthly bill for cell phone users has decreased from the 2001 mean. Since we're looking at decreased, we want less than, and we use the $41.41. The alternative hypothesis is H(a) colon mu less than $41.41. Classify the hypothesis test as two-tailed, left-tailed, or right-tailed. Since it is less than, we want left-tailed. Alternate hypothesis. If the primary concern is deciding whether a population mean mu is greater than a specified value mu sub 0, we express the alternative hypothesis as H(a) colon mu greater than mu sub 0. A hypothesis test whose alternative hypothesis has this form is called a right-tailed test. Example: cadmium, a heavy metal, is toxic to animals. Mushrooms, however, are able to absorb and accumulate cadmium at high concentrations. Some governments have a safety limit for cadmium in dry vegetables at 1.8 parts per million ppm. A hypothesis test is to be performed to decide whether the mean cadmium level in a certain mushroom is greater than the government's limit. Determine the null hypothesis. The notation for the null hypothesis is H(0). We are looking at the mean cadmium levels, which is mu. H(0) is always equal to, and we want to compare it to the government's limit, which is 1.8 parts per million. The null hypothesis is H(0) colon mu equals 1.8 ppm. Determine the alternative hypothesis. The notation is H(a). We are using the mean mu. Our hypothesis test is to decide whether the mean cadmium level in a certain mushroom is greater than the government's limit. We want to use greater than 1.8 ppm. The alternative hypothesis is H(a) colon mu greater than 1.8 ppm. Classify the hypothesis test as two-tailed, left-tailed, or right-tailed. Since it is greater than, we want right-tailed. Basic logic of hypothesis testing. Take a random sample from the population. If the sample data are consistent with the null hypothesis, do not reject the null hypothesis. If the sample data are inconsistent with the null hypothesis and supportive of the alternative hypothesis, reject the null hypothesis in favor of the alternate hypothesis. Type 1 and Type 2 errors. Type 1 error, rejecting the null hypothesis when it is in fact true. Type 2 error, not rejecting the null hypothesis when it is in fact false. We have a table to help us negotiate the different types of hypothesis tests and decisions. Our columns are for h sub 0. The column to the left is when h sub 0 is true. The column to the right is when h sub 0 is false. I have two rows for my decision. My first row, my decision is do not reject h sub 0. The second row, my decision is reject h sub 0. If I do not reject h sub 0 and h sub 0 is true, then I have made the correct decision. If I do not reject h sub 0, but h sub 0 is false, I've made a type 2 error. If I reject h sub 0, but h sub 0 is true, I've made a type 1 error. If I reject h sub 0, but h sub 0 is false, then I've made the correct decision. Example: in the past, the mean running time for a certain type of flashlight battery has been 8.4 hours. The manufacturer has introduced a change in the production method and wants to perform a hypothesis test to determine whether the mean running time has increased as a result. The hypotheses are h sub 0 is mu equals 8.4 hours. H sub a is mu is greater than 8.4 hours, where mu is the mean running time of the new batteries. Explain the meaning of a type 2 error. For a type 2 error, we do not reject h sub 0, meaning mu does equal 8.4 hours. However, when you make a type 2 error, that means h sub 0 was actually false. And our conclusion should have been mu is greater than 8.4 hours. A type 2 error would occur if in fact mu is greater than 8.4 hours, but the results of the sampling fail to lead to that conclusion. Example: a manufacturer claims that the mean amount of juice in its 16-ounce bottles is 16.1 ounces. A consumer group wants to perform a hypothesis test to determine whether the mean amount is actually less than this. The hypotheses are h sub 0 is mu equals 16.1 ounces, h sub a is mu is less than 16.1 ounces, where mu is the amount of juice in the manufacturer's 16-ounce bottles. Explain the meaning of a type 1 error. For a type 1 error, we reject h sub 0, meaning we think that the mean is less than 16.1 ounces. However, h sub 0 was actually true. A type 1 error would occur if in fact mu equals 16.1 ounces, but the results of the sampling lead to the conclusion that mu is less than 16.1 ounces. Significance level. The probability of making a type 1 error, that is, of rejecting a true null hypothesis, is called the significance level alpha of a hypothesis test. Relation between type 1 and type 2 error probabilities. For a fixed sample size, the smaller we specify the significance level alpha, the larger will be the probability beta of not rejecting a false null hypothesis. Possible conclusions for a hypothesis test. Suppose that a hypothesis test is conducted at a small significance level. If the null hypothesis is rejected, we conclude that the data provide sufficient evidence to support the alternative hypothesis. If the hypothesis is not rejected, we conclude that the data do not provide sufficient evidence to support the alternative hypothesis. To recap the section, the nature of hypothesis testing, null and alternative hypothesis. H0 represents the null hypothesis. H represents the alternative hypothesis. The null hypothesis is always equal to, and the alternative hypothesis can be less than, greater than, or not equal to. The alternative hypothesis also decides if we have a left-tailed, right-tailed, or two-tailed test. Type 1 and Type 2 errors. Type 1 error occurs when we reject H0 when in fact H0 is true. A Type 2 error occurs when we do not reject H0 when H0 is in fact false. Significance level. The probability of making a Type 1 error is your significance level, alpha.